All right, we're not muting our mic today, I promise. I think. So, good evening. Today we're gonna just continue our topic from last time, which was on technically it was on artificial intelligence and the use of artificial intelligence in games such as Go. The enterprising viewer will see that we have picked up exactly where we left off in the game last time, where we were explaining the game, but didn't actually get to the AI part. So let's talk about the AI part. Essentially, what AlphaGo is about is it takes in essentially a matrix of numbers. So 19, essentially 19 by 19 numbers. Or rather, it takes in information in a 19 by 19 grid. And, 0 if there's nothing there, 1 if it's white, 2 if it's black. I assume something along those lines. And it runs these, and it doesn't know much about the game. In fact, AlphaGo Zero, which is the new version, AlphaZero, which they're using to learn all sorts of interesting games, knows nothing about the game. And so instead of hard coding rules, we actually let the game figure out the rules on its own. So, of course, the game needs to know that only black and white go alternatively, and that's it. And so in this case, the Google team fed it who knows how many games, fed it a whole bunch of games so that it had. Actually, let's talk about the neural net first. It's they don't really give you enough information per se. There's enough code, but they don't give you the weighting for what each node ends up doing. But essentially what happens is the game takes in a board like this in SGF file, which is sort of the SGF. Oh, you can't see. SGF is a file format for just these Go games. It takes in an SGF file and reads the board in its current state, and then it has a whole bunch of outputs that then determine where let's not say outputs. It has a whole bunch of internal weightings. So it has a whole bunch of, like, each of these points on a grid is an input, and all those inputs lead to a whole set of secondary internal inputs, and they propagate inside or amongst themselves for a little bit, and then it spits out a few numbers in terms of where it thinks it's best to go next, and what it thinks the probability of going next will win is. And so up here we can already see that given this particular board shape, well, this is okay. Let's go back a notch. We don't have access to AlphaZero because that's proprietary and Google owns it and won't share it with anyone because they're cheap, and because they apparently work in open source. That's how it works. That's how open source works with big companies, by the way. They call everything open source and then they leave the most quintessential elements for themselves. Fucking guys. Anyway, don't use Chrome. Anyway, so this is Lila Zero, which is an open source implementation of the AlphaZero code. As far as we can tell, it's an exact implementation of the AlphaZero code, and we, as in the open source community, have trained this AI based on our own sample games and our own essentially people, and we've come up, and so like not only can we play against it and teach it and feed it a bunch of games and teach it, it can also play against itself, right? Which is also something AlphaGo does. and so it can play against itself, and so it can play itself a billion times and learn from that. Of course, it's not an exact copy of itself, because then you don't actually learn anything, you're just reinforcing what you are, which, as an aside, is particularly interesting to when applied to humanity, isn't it? When we're just by ourselves and focused on ourselves, we're never improving, we're just reinforcing what we are. And that's exactly the same thing here. So we have to, every time we make the AI play against itself, i.e. something like engine versus engine game, we can we can change certain minor parameters inside so that the engine, the two engines that are playing each other, can't actually guess where the can't reliably guess where the other is playing, and so that generates sort of new information, which is particularly interesting because that's technically also how the human brain works. But anyway, we're getting off track. So Leda Zero, that's what we're using in this open source implementation of AlphaZero, and we've taught it very, very well now. And so back to this part up here on the top right, we see that there's a white, and then that's 63%, which means that can we actually see this tooltip? Oh no, we can't see the tooltip. Can we? No, we can't see. But anyway, okay. The tooltip really only says that it's that white is winning has a 63% chance of winning. And so, you know, how does the engine know this? Well, the engine knows this because once we turn on the heat map, we can see where the engine thinks the next optimal move is. And you will notice that there's a 36.5 here, and there's a 36.2 here. So that means if black goes in this position, it has a 36.5 chance of percent chance of winning. And if black goes here, the engine itself, so Lila Zero, thinks there's a 36.2% chance of winning. Everything else is the engine doesn't know. The engine thinks it's crap and that you shouldn't do it, essentially, right? So 32%, 34%. And if you refer back to our talk from last week, you'll notice that I did speak also on the ideas of essentially getting into the back behind the white lines to take away some of the white territory. Anyway, so the engine right now thinks that going here is the best move, and it's plotted out a whole bunch of what it thinks the moves will be going forward for black to achieve that 36% win percentage, and for white to essentially be winning at 63%, right? So that's really all there is to the AI. We can talk about the inner workings of the AI a little bit more, but that's mostly mathematics. And I don't think any regular listeners actually know enough mathematics. And isn't that just kind of sad? Anyway, so we'll move on with what the engine has suggested. And we see once again, now that we're in white's, what do we call it? Oh, we are in white's phase. And, whoa, look at that. The percentage win chance for black is increasing. And that kind of makes sense because we're still quite early in the game. And we can see that white has a 63% chance of winning out of, however, that's 235,000 possibility spaces that the engines themselves have considered, right? So as the longer we linger here, the longer the engines get to calculate all sorts of counterfactuals. And for reference, counterfactuals like what we do here, right? Like this would be a counterfactual to this game where we branched off at this point, and you know, like I love this program, by the way. You see all these different points where we've played. Let's see. This will be an alternate counterfactual for the astute reader, the astute reader may remember that this is something that we did last time. Oh, you see, in this case, we went here as black, but it suggests for black to go in this direction. And suddenly, white has no more real... white is winning quite a bit less. Black went in this direction. That's interesting. Is that what we did? Oh, that's not what we did. Yeah, okay. So anyway, let's go back to this particular plot, which is our original, well, my original me versus myself game, as opposed to an engine game, and continue from here. Thank you. So this, as the engine suggested, we go here. And of course, in these particular cases, we can always turn the engine off and then think for ourselves for a moment. And we do know that the engine has recommended 314. And it looks good, doesn't it? Because what 314 ends up doing is it allows us to protect this corner, and this area under here is protected by this in some amount of in some amount already. And I think the more artistic or abstract thinker can sort of see that there's a projection of black territory that comes from this area that goes down here. That's not to say that we can't make white work down here. So something like this. Let's see what the engine say to this. Something like this would, as you can see, the more games that are played for black, oh, win percentages are going back up. No, they're not. Nope, they're going back down. So it's obviously still better than before, where the engines would recommend something like this for white to create space here, and excuse me, and white would have a higher percentage of winning here. But so if white went here, let's see if the engines recommend, how the engines recommend that white plays. That's 15,000. The engine actually recommends that we just forget about this area. Interesting. So it's very hung up on the top left here, because there are more, how do we say, there is less how do you say it in English? There's more case for strategy, so bigger picture strategy up here, whereas if we continue in this area, it's much more a tactical what? Tactical knife fight. Yeah, let's go with knife fight. So anyway, so if we're here and the engine suggests and continues to suggest here, and you can see that there's an actual difference between placing on the fourth column or the third column, and that's particularly because of just how it affects the center in the future. If we start on a third column, you can see that black jumps out towards the center, and so suddenly everything in this area becomes more black. Whereas if we do it the other way, I think it becomes very easy to see that we are actually forcing black into the upper left corner. Even if black, as the engine suggested, run this in this direction and tries to come out here, we can lock it down here and then claim all of this, or try to claim all of this for white. Oof. Let's see. Oh, okay. We're a little bit tight on time today, so let's just go back here for one brief glorious moment and say that instead of taking the smart option and going for the top left, we want to actually play down here. Let's see what the engine says. And now you see suddenly black is in such a huge advantage because this particular stone that we're attacking with 38 actually has 37. It has 9 to back it up, and it has this particular set of stones to back it up. So with this one placement on 417, we're essentially cutting off the ability for this part of white to do anything on the base layer down here. So that's why a move like 38 would not really work. Now, what if we were more conservative and we tried to do something like this? Isn't it funny that suddenly black is now in the lead and has a much higher percentage chance of winning? Whereas even something down here did it. And that's simply because you're giving up a lot of room in this area. Remember, in the previous move, if we had gotten... If we had pursued this particular counterfactual, black would be locked into the top left, and that would have made it almost impossible for it to come out, which means all of the center and top center and top right belongs to white, and that gives white a much better base of territory from which it can build onto. Whereas if we did something retarded like go down here, suddenly you see black is able to extend itself to the right, and therefore consolidate territory, not so much on the top, no, but on the left. And I think it becomes very obvious that suddenly the left side is now very heavily favored for black, and even the bottom center is also favored for black. Anyway, that's it for today. We didn't actually play many moves. Next time we might actually play the game, which would be interesting. In conclusion, I got shit for saying this and for saying this every time now, but I will say it anyway. Please don't use Chrome. Please use Firefox. All right, just do us all a favor and download Firefox. Okay.